All right, so we're going to take a look at an example of how we get acceleration from a velocity time graph. So example 1.3.1 says, what is the acceleration of the skateboard in figure 2? Consider the motion between 0 seconds and 10 seconds. So the first thing that we need to notice is the type of motion graph that we have. And if you look at the left here, on our y-axis, we see that it is velocity in meters per second and that we are moving south, and we have time here on our x-axis. So really, it's very similar to the same way we got velocity from a displacement time graph. So in order to find the acceleration, we really are just looking for the slope of this line. Okay, when it is a constant slope like that, finding the slope will give us that constant acceleration value. Okay, so we're going to look at the 2 points here at 0 seconds and here at 10 seconds. Okay, so at 0 seconds, we can see that our velocity is 0 meters per second. Okay, at 10 seconds, we've marked this point on our graph, so we just need to go over to the y-axis, and we see that that corresponds to a velocity of 30 meters per second south at 10 seconds. Okay, so much like the same way we found velocity from a displacement graph, we're going to find the slope, which is really just y2 minus y1 over x2 minus x1. In this case, our y2 is going to be that second velocity, okay, at 10 seconds, minus our first velocity that we see at 0 seconds, okay? And it's going to be divided by our x coordinates are, in this case, are 2 different times. So on the top, we're going to get 30 meters per second minus 0 meters per second. And that's all in the south direction, divided by our times of 10 seconds minus 0 seconds. Okay, so that gives us 30 meters per second south divided by that total time of 10 seconds. So our average acceleration over that time is 3 meters per second south. Okay, you'll notice that the sig figs in this graph are only 1, so therefore our acceleration over the time of 0 to 10 seconds is 3 meters per second in the south direction.